Don't you like paying more for something when it's on sale? We're going to talk about 12.3. It's the final section of chapter 12. It has to do with regulation of the cell cycle. And there, in objective 15 here, you'll see that there are both internal and external factors that influence this regulation. Additionally, we're going to talk about cancer in objective number 16, and then we're going to I want you to be able to distinguish between the different types of tumors that may exist as a result of uncontrolled cellular growth. But first, I want to remind you about the cell cycle. It's really the process by which cells divide, and it's regulated by a molecular control system. The frequency of cell division varies within cells. You'll read in your book that muscle cells and nervous tissue cells actually never divide. And there are some cells like skin tissue cells and cells in our stomach and intestine that are constantly dividing. Their goal is to protect us and then just be sloughed away and replaced by a new cell. So it varies within cells. And this difference is dependent upon influences at the molecular level, meaning the stimulation of this cell division system. I don't want to do too much right now. I could talk to you about the hormones that might bind to the DNA which stimulate this, but we're not going to go there just yet. Let's just look at regulation of this system. So if you see here, there's 3 different checkpoints, and there's a cell cycle control system at each checkpoint. So you can imagine here, let's look at the G1 phase of the cell cycle, for instance. Each one of these boxes is an artist's representation of some processes that need to take place within that box in the replication of, say, organelles or things in the cytoplasm. And that box suggests that the things that need to take place within that dividing tissue have to take place correctly, and then there's something that takes place after that, and again and again and again. You can see that. And then finally, after maybe 20 or 25 different processes have taken place in a very sequential order, there's a checkpoint. And this checkpoint is like a guard, and it's saying, hey, has everything happened correctly? And if it has, then the division or interphase will continue. If it hasn't, what occurs to the cell is something called apoptosis, or the cell goes into this non-dividing or G0 phase, and then the cell will die, basically. And the whole reason why we've evolved to have this is for protection, so that we don't have cells that haven't done the right processes dividing and then making new daughter cells exactly like them. That would lead to cancer and to bad things very quickly. So this just talks about the different checkpoints here. Let's go into a little bit more detail onto how the checkpoints work. So you see down here in A, it says cell receives go-ahead signal at the checkpoint, and if that takes place, no problem. The cell's going to continue to divide, and if the cell does not receive the go-ahead signal, then it will not divide. There seems to be a protein called cyclin, which you're going to read about, that exists in really high levels if the cell is doing well and division should take place. There's also a player called CDK, and what it is it's called a cyclin-dependent kinase. Go back to chapter 11. I hope that you can press pause, just flip real fast back in your book to chapter 11, and remind yourself what a protein kinase is. It's part of something called a signal transduction pathway, and it allows things to happen in the cell, and in this case, cell division. It looks like this G1 checkpoint's pretty important. Here's some more information on that. And we've already talked kind of about what might happen if the cell ignores the checkpoint and continues through the cell cycle. It could be really devastating for the cell. So here's some protein kinase activity, and you can see here some results. Take a look at this experiment in your book. Obviously, where the protein kinase activity is high, you see a correlation over here with dividing cells that is also high. The cells need this protein kinase activity, and specifically this cyclin, to be high in order to be able to divide. And where the level of it over here on the left axis is low, you see that there's not many dividing cells. Press pause and take a look at this graph. Here is cyclin. Cyclin is bound here to this MPF, which is just this dependent kinase. You can see it here. The CDK is really the dependent kinase alone. Cyclin is also alone, but when they're together, it's called an MPF. And the whole idea is that cyclin is the major player here. It's a protein that's going to allow the cell to continue through these checkpoints if the appropriate processes have taken place. You can see here also that every time mitosis occurs, cyclin concentration is really high, and you can see that MPF activity is really high as well. Here it says cyclin accumulation. Over here on the right hand side is accumulating. Cyclin's accumulating as interphase is going on.
How is growth of cells controlled? Each growing cell binds minute amounts of positive regulatory proteins called growth factors that stimulate cell division. A specific cell surface receptor recognizes each growth factor, its shape fitting that growth factor precisely. Growth factors work by triggering intracellular signaling systems. Binding of a growth factor sets in motion a cascading intracellular signaling pathway, usually involving phosphorylation of proteins, which activates nuclear regulatory proteins that trigger cell division. For example, the retinoblastoma protein, RB, is a molecule that interacts with many key regulatory proteins of the cell cycle, depending on its state of phosphorylation. When RB is dephosphorylated, it binds to and ties up regulatory proteins such as MYC, which is a protein needed for cell proliferation. When phosphorylated, the RB protein releases its captive regulatory protein, freeing it to act and thus promote cell division. Free of RB inhibition, cells begin to produce cyclin-dependent protein kinases, CDK, and cyclins, and proceed through cell division.
Make sure that you check out figure 11.9. It's going to talk to you about protein kinases as well as how they phosphorylate things. Go back to that video I just showed you if you need to. Let's just answer objective 15 right now. We'll get to cancer on the next little podcast. Thank you.